Now, why the dimension analysis are so important, as I discussed earlier, we need to identify if the formula is correct or it's not correct. So, for example, we got a formula here. We got two formulas. It's about the time period. Time period equals 2 pi square root ml over f. And then we got another formula. Time is equals to 2 pi f over ml. Yep. So I need to find out the time period for vibration, which one is correct, which one is not. Usually, the time period is represented by an uppercase T. I don't know why they put a lowercase t, but just to give you an idea. Now, here we got F is a force, M is a mass, L is a length. Yeah. 2 pi doesn't have unit. Number 7, number 8, number 69. 69, 54, 72, they don't have units. So we assume there is no unit. So that doesn't matter. But the units for this left-hand side should be equal to the unit of the right-hand side. Only then they will be equal. The formula is correct. So I start with the first formula. And then we actually see if... now I want to check this formula A to see if that works. Let's start with, this is my left hand side. So left hand side, LHS, left hand side, which is time, isn't it? The time, what's the unit for the time? Seconds. Yep. And how do you write the dimension for the second? T in this square bracket. Yep. So that's that one done. Now I want to have a look at right hand side. So I'm just going to do right hand side here. Right hand side. What we got on the right side? 2 pi m L over f. So let's have a look. 2 pi does not have any units. So that doesn't, I'm not bothered by 2 pi. Yep. So what is the unit for m? Is mass, isn't it? I can write the unit now or I can write it later. But before I do that, I can do an easy way. That will help me a lot. What is F? F equals to MA, isn't it? That's the formula for that one. And that is M and L. And M is mass and that's mass. So that makes my life a lot easy. I can just cross them out. Once I cross them out, let's have a look at this one. Here, this is length. Length, the unit for the length is meter divided by unit for the acceleration is meter per second square. And do not forget that square root sign over here. Now I can cancel that. This is a unit for the length. Yeah, this is meter. Remember that one, there's a m and the m, so don't get confused. And this is also meters per second. So I can cross this and that as well. Remember, this was mass, but this m is actually a meters. Yeah, I just put MET. Now, according to the law, there is a division and another division. So that square should go on the very top. And you know that will cancel each other. And you will have just a second. And the dimension of that one second is a t. According to what we have done so far, if we have a look, dimension of the right hand side are equal to the dimensions of the left hand side. So this formula A is correct formula. Yep. Now let's say we got another formula, T equals 2 pi F over ml. We want to see if this formula is right or this formula is wrong. So let's start with left hand side. Left hand side we got T. and we know t is second, and we know that is second is a t here. Now, once done, I need to look at right hand side. To do right hand side, I got 2 pi f over ml. 2 pi is insignificant because it's a number. And again, f is ma, and that is ml, and then a square root. Cross this out, cross this out. Now, after that, we put the units. The units for the A is meter per second square. And unit for this length, which I can put here, it is meters. Now remember, this one is a meter, this one is a meter. This is not the mass. This one was the mass. Yep. You can cross this one and this one. Do not forget the square root sign. And now we got square root 1 over s square. If I simplify, that will give me 1 over s. And you know the dimension of s is t. So that would be 1 over t, which if I bring it up, will give me an answer as t square bracket minus 1. When we look here, dimensions of left hand sides are not equal to dimensions of right hand side, which mean this formula is incorrect. Here you can write down like that's not consistent with the dimensions of the t, a period of vibration, which mean the second formula is incorrect, whereas the first formula, where right hand side and the left hand side they have the same dimension, so that's a correct formula. Yep. Now let's say in a question we got a different formulas. We want to use the method of dimensions, length, mass, MLT, LMT, yep, to find out whether the following formulas are dimensionally valid or they are invalid. Now here, what is U, what's V? U and V are the velocities. U is the initial velocity, V is the final velocity. G is the acceleration due to gravity. S is the distance, and T is the time. So that these things will be defined. So you're supposed to know at the start of the question that what are these values. We'll look at this one and see if we can find if that's dimensionally correct or is dimensionally incorrect. What's the dimension for, let's start with left hand side. What's the dimension of the velocity, or not dimension, units for the velocity? Meter per second. Okay, so that's meter per second, and obviously that has to be a square because there is a square there, so I need to square that one, which will give me meter square over second square. Meter is L, length, so length square. Second is time, so time square. And if I simplify that one, that will become a L square, and that will be a t minus 2. So I have got this dimension. So these are the dimensions for my left hand side. Now I need a dimension for my right hand side. On right hand side, what do I have on the right hand side? U square plus a 2gs. U is again a velocity, and the unit for the velocity is meter per second, and that's a square as well. 2 is a 2. 2 is insignificant. We don't deal with numbers in dimensions. G is acceleration due to gravity, and that is meter per second square. And this s, remember, this s is the distance. How do we know? When we read the question at the start, this is not the second, this is actually distance. So what's the unit for the distance? Yep, it's we're looking at units, so meters. Now let's have a look at that one. This thing becomes a m square over s square, plus this thing becomes a m and m, that will be an m square again over s square. When the dimensions are same, you can just add them. When you add them, that will be, let's say, is 2 m square over s square. Yeah, because that's that one and that's that one, that we can add them, that becomes a 2. You got something and another something, that's 2 of something. Now that 2 is insignificant. Now we convert that into dimensions. M is length square, divided by second, which is a time square. And I can write that one as length square. When I bring the time according to the rule of indices, that can be a minus 2. And if you have a look, the dimensions on this side is same as dimension on that side. So which means this formula is dimensionally correct.